Well, on Wednesday, the Health Secretary, Jeremy Hunt, heralded the results from £2 billion worth of research across the past 13 years into the human genome. Now the 20,000 genes and the DNA between them that create every individual's genomes can be codified by 3 billion pairs of letters. And today it only costs £1,000 and 2 days' work to read every single letter. It is going to completely transform the way doctors will understand diseases and treat them. It's also going to transform what you can find out about yourself, where your ancestors came from, how you can best maintain your health, and what diseases you have a higher risk of suffering. Should we all know about our genes? Shane McKee, a consultant in genetic medicine, Belfast Trust. Right, thrill us. Tell us about this brave new world.
Nicky, we're living at a time of enormous revolution in health science and health care. 1 person in 17 in the UK is living with a rare disorder. About 80% of those disorders are genetic, so they're encoded within our DNA. We now have the technology that allows us to reach into that DNA and find the causes of those particular problems. So that's a huge number of people. Those are people who require a great deal of care, but they're people who often get left behind and lost in the overall melee of health. But more than that, these people are actually bringing a lot of value to the rest of the people who have more common disorders, because we're now starting to find out that rare disorders are very often biologically showing up the pathway to understanding common disorders. Disorders like Huntington's disease are telling us lots about Alzheimer's disease and Parkinson's disease. They're giving us ideas about therapies and treatments that we can potentially bring in and start trying to treat these conditions.
Huntington's, it affects your insurance premium.
It can affect your insurance premium, but I think more importantly than that, it affects your life. So these are things that we've got that...
yes, but if you're identified as merely having a potential, this is the area I want to talk to you about, potential susceptibility. If you were, if I may, you went to find out, about your high cholesterol or something, and you went there and got a reading of your genome, and they saw that you had a propensity, possible potential predilection for a terminal illness. A, would you want to know? And B, should they have an obligation to tell you?
Yes. Because this is my information.
Yes.
I'm walking around with about 2 gigabytes of information in my DNA. I'm effectively like a USB stick, and I want to be stuck into a computer for something to actually analyze that and tell me information that I need to know. If I'm sitting on a time bomb, what I want to know is, do I cut the red wire or the blue wire? I want to know, can I delay the onset of that time bomb? And I want to know, can I mitigate the damage to other people around me? So these are pieces of information that I think are vitally important for us to know, but also to uncover more about human biology and human medicine in general.
Oliver, does it excite you? I mean, would you want to know if you went to get your cholesterol potential tested?
It's a fact, not my opinion, Shane, that certainly in the sphere that I am expert in, that is psychological matters, personality, mental illness, mental ability, that there have been no genes identified which predict what you're going to be like, what your outcome is going to be. That is a fact. It's not my opinion.
In a very small area.
Can I just finish, please?
Yeah, sure.
It is a fact, not my opinion. To back it up, the main gene scientist in this area, in this country, a guy called Robert Playman, said, recently quoted in The Guardian, I have been looking for these genes for 15 years. I don't have any. Okay?
Yet.
So when you... No, not yet. Everybody knows molecular geneticists off the record, obviously they want to go on getting paid, but off the record, they admit they have looked everywhere. They looked under the bed, they've looked in the attic. They are not going to find them. The model of the biogenic model, certainly in the sphere in which I am expert, has collapsed completely.
But Angelina Jolie, she found out she had a faulty BRCA1 gene. Her mother had died, breast cancer. Her grandmother, likewise.
There are, in the physical sphere, of course it's true that there have been found some genes, but you are, I suspect, massively exaggerating. You say 1 in 17, of which 80% is genetic. I can't challenge you on that statistic because I'm not an expert in that. But what I can challenge you, there is a website of a gentleman who we're going to hear from soon, in which they actually state that they can allow personality characteristics to be predicted using a DNA analysis. That is a lie. That is simply untrue.
I think sorry, Shane. Naturally, we come back, but the gentleman in question should have a natural right to respond to that.
This is Craig.
Craig, but I will come back to you. Craig, what about that?
Yeah. So at the moment, there are 60 companies that sell consumer DNA tests in the UK. Some of them are very responsibly sold, some of them aren't. There's not enough legislation, we need to have the debate. I wanted to shine a light on those by putting them all up
Are they
there.
selling false hope and also false fear?
Certain tests, definitely not. There's really robust research about breast cancer, for example, predisposition to prostate cancer, Alzheimer's disease.
A handful. These are very few.
No, I completely
Admitted.
disagree. There are hundreds of genetic
Yeah, they're
conditions.
hundreds, but they're tiny. They're
In terms
illnesses that are extremely rare.
In terms of
Let
things
us speak.
like sporting ability, musical aptitude, personality testing, it's in its infancy. It's really
Not in
early
its infancy.
stages.
Sorry, they have proved pretty conclusively that genes do not play a role.
That's
in
not
that.
true at all.
Yes, it is
We've been
true.
able to sequence a human genome, but we don't know what everything does yet.
On the contrary,
There are 11,000
absolutely
papers
untrue.
published every month about genetic research. It's a massive area, and
I'm
we
sorry,
know
that-
only very little. We know about single gene mutations. For breast cancer, there are thousands of genes that are believed to have an impact. 3, we know, have a massive impact, but we're still learning how they all interact. DNA
No,
is
we're
not the whole picture.
Rubbish.
DNA is not the whole picture.
That's just a lie.
If I might come back in.
Michael, you can, but I need not that you're not an honest broker, but I need another honest broker.
I
Michael,
think the discussion's getting a little bit muddled because we're talking about...
susceptibility testing.
Right, well, let's contrast that with the traditional model of single gene disorders, which have been incredibly useful for identifying rare disorders, of which Huntington's disease is the pin-up boy. That has been incredibly useful for families to identify these genes. If you have this gene, and we can identify this at birth, although we wouldn't want to test a child at birth, but if you're positive for that gene, you are 99.9% guaranteed to have that condition later in life. It's a late onset disorder. That's wonderful that we have that technology that's available. The other issue that's implicit to the question that we're debating here, though, is do we have a right not to know? So that's also an issue, and we can't do this alone. A genetic test is not this neutral device that reveals the truth about our biology. It is an interaction with somebody. It is an interaction with a technician, with a genetic counsellor, with a clinical geneticist, and they have to interpret what that information means through very careful procedures. In the medical model, where single gene disorders are tested for and disclosed, there are very rigorous procedures where counsellors will take you through the various steps of understanding the ethical, emotional, practical consequences. Do you know what you're asking for?
Yes.
And do you know how you might disclose this information to other family members who might also be at risk? So these are urgent issues. But what's been clouded in this discussion so far is that there is another sphere of liability or risk that we can divine from our genome, which is called the realm of susceptibility.
Yes.
And susceptibility are polymorphisms which confer very, very small risk-odd ratios. So, like height, personality, all the kind of familiar characteristics that make up a person are all polygenic, yes, but it might take thousands of these susceptibility genes interacting in unknown ways with the environment on top of that, that produces a personality, that produces common complex disorders like heart disease, Alzheimer's, Parkinson's.
So it's way too complex to
It's
flog on a
way
website.
too complex, and the more that we know about the genome, the more that we realise that we don't know. And there are areas of non-coding DNA, we don't know what that does yet. So offering a
so-called junk
test
DNA, yeah.
on the basis of a small panel of susceptibility genes offered by these companies, and you're right, some of them are responsible, some of them are complete charlatans, that offer a very small range of selection of these SNPs and being able to promise or offer the impression that we can give you a risk for Parkinson's disease and Alzheimer's is incredibly partial and incomplete, and I wouldn't buy the test because it's not worth the paper or the screen that would appear on.
I really should go back to Shane, his contribution has been delayed, but go on, David.
Can I just ask, I mean, we understood about these single gene disorders, didn't we, way before the sequencing of the genome?
Absolutely.
I mean, the sequencing of the genome, which happened, 15 years ago, has produced remarkably little, hasn't it, in terms of successful
Exactly.
medicine?
That's
Okay, time for Shane. Time for Shane. Wait in a minute.
There is, in the scientific community, something called the missing heritability.
That's right.
And what they mean by the missing heritability is actually we can't find anything.
Yeah.
But
But
so
it
that
doesn't
is
mean
the
that it doesn't
truth.
exist.
Shane
Oliver Oliver
McKee.
is confusing two issues here. The issue of 1 person in 17 with these rare disorders, as I mentioned, 80% of those are genetic. These are important people, and these are people who make up a large proportion of the people in this room. This is not medically irrelevant. I completely agree that the susceptibility margins of error that have been put through for a lot of these things, and this missing heritability, those are real issues, and those are actually correct issues to discuss. But medically, those are not particularly important. If I want to know that why Aunt Annie is a bit of a weird fish, I'll not do a gene test on her. I'll send it to you, Oliver. And I'll see what I can get. But I have, in my clinic, patients coming in who have got rare disorders where we haven't been able to make a diagnosis.
Shane.
We have done a genome sequence on those people through a research study. There's one going on in Cambridge at the moment that we're involved in, and we're finding answers for those patients.
Yeah.
We're also finding areas where we can understand the biology
And you
of
can
their
tailor
condition
medicine
better.
to those
And
particular
tailor medicine.
patients. I want to ask one more. I want to ask one more as well.
Correct.
What about there are certain conditions which are maybe not polygenetic, but they're clearly genetic. Is it possible then to limit their manifestation and to eradicate
Yes.
those diseases over the years? How would that work?
A brilliant example of this is a genetic condition called tuberous sclerosis, which we've known about for a long time. 50 years ago, it's the 50th anniversary this year, a scientist working on Easter Island dug up a sample of soil, and researchers back in the lab found that this soil contained a chemical that was produced by bacteria that slowed down the growth of cells. They were able to identify the target of that chemical. It's a drug. They developed it into a drug called mTOR, called rapamycin. The protein's called mTOR. We can now use that drug, or molecules based on that drug, to slow down the progression of this disease, to cure renal cancers in these patients. And it even affects their brain development and...
But also, if there's
development of
Huntington's in the family or something else, through IVF, that can be...
And again, and things like that, we can predict whether people are going to be at risk of having a child with that. We can do an IVF technique called pre-implantation genetic diagnosis.
The genome? I mean, that's
This is how we know. This is how we know. I mean, if we go around with our eyes closed, how are we going to know anything? We don't know anything.
So understanding the genome through Sarah Nordwall, IVF, understanding the genome and being able to make sure certain life-shortening conditions do not appear in your children. What do you think of that?
One of the principles...
I know you don't like it, do you?
One of the principles that we're trying to preserve in the transmission of life, one of them is that you can't take a life to make a life. And so the first thing you have to do is make sure that when you're dealing with embryos, you are dealing with human persons. That's something you would say. And if you disagree with that, then that's a completely different foundation for your activity. But that's the first thing, is that you're dealing with human persons. You can't take a life to make a life. The means don't justify the ends. And if you are happy to sign off some of your embryos to medical research or commit to abort people, which is in the Catholic Church's view and many other people's view who agree with non-violence, to kill people to help other people be healthy, it's mixing your ethics. Because not everything you can do, you should do.
Oliver, in a
means don't
second. Shane,
justify
come back on
the ends.
that. There's a theological, ethical, philosophical wall between the two of you, clearly. We know
Well,
that,
I think that actually we're probably more commonly aligned than it might appear.
I don't think
it's a totally separate debate. But I think Craig was right to mention that we've got these two separate issues here. One is the very important and much more common than people realise, genetic disorders that we're trying to diagnose using the Human Genome Project. And also then there
You're trying to diagnose or eradicate.
Well, diagnose, eradicate, people sometimes think, well, if you just get a name for it, that's no good. But getting a diagnosis, if you're a patient with a rare disease, getting a name for that condition and knowing what it is and being able to be put into contact with other people who have the same problem and are going through the same thing, that's immensely powerful. And that's a fruit of the Human Genome Project. That's something that we can point to specifically and say that we can do that.
We
The Human
absolutely
Genome
have
Project has
nothing
definitely
against
come up with some very useful things. Without doubt, if I got cancer, I would want you to be looking at my genes and seeing if you could switch on and switch off genes. That's true. But let's not get distracted. The Human Genome Project, the main thing it has shown is that the vast majority of traits, to a very large degree, are not caused by genes. Whether I'm an outgoing, overly loquacious, opinionated man or not, has everything to do with the way I was brought up by my parents. And almost nothing, traits are passed from parents to children.
Have you ever
It is
met
now
a pair of
very, very
identical
clear
twins?
in terms of personality and psychology.
Have you ever met a
The
pair of
twins test
identical
has been
twins?
disproved by the Human Genome
Identical
Project.
twins share the same genome.
No,
There
sorry,
are
don't start talking about identical twins. Everybody, as a geneticist, you would always agree that we look at the genes first, not twin studies.
Oliver,
No,
let's,
it's not- I'm not
well, I
talking
tell you
about
what,
twin studies.
quiet everyone. Just let's have a moment. That's nice. Shane.
Okay, I'm not talking about twin studies. I'm talking about looking at identical twins, and we can see that there are physical traits that identical twins have that are different from the physical traits that are shared by dizygotic twins or non-identical twins. We know this to be the case. We know that the genes are heavily important.
That's what twin studies are. Yes.
Yeah, but I think you're trying to
Twin studies. What the
separate
point
it
about
out.
twin studies is what they've actually shown is that twins are treated more similarly because they look similar. That's why
But
they're more similar.
Yes, but they
And
look
so
similar.
it's not
Shane,
to do with their genes.
Okay, we're getting the gentleman back there with your hand up. Yeah.
There are two
Gentleman back there with his hand
studies.
up.
Okay, thank you. I'd like to address a point that was made earlier about an embryo being a human being. It's in no way, shape or form like a human being. If you ask anyone what is a human being, they wouldn't say an embryo, and leave it to someone from the Catholic Church to try and deny science again in such a modern age of science. It's just absolutely ridiculous. It's a completely ridiculous point of view.
Yeah, in a way, so it's another debate which we've had before, and I
But
think you were
why
on
would
it.
we be interested in DNA if we didn't think that it was human? Surely, the Catholic Church has absolutely nothing against science. You know, my cousin is married to a doctor of genetics, and the whole point is most of what you're doing is probably absolutely fantastic.
There's
It's
DNA in
fascinating.
cabbages. It's part of life. It's the structure of life.
He's
Peter,
just said it isn't a human being. Well, why would we
Peter-
be interested in human DNA if it wasn't human? The whole point is science supports what the Catholic Church is saying.
You clearly, look, you and your brother, you had the clever gene, right? No doubt about it.
Not everybody agrees about that.
Any thoughts on this?
No, I try and steer clear of things I don't know anything about.
Peter, you were asked to do it. Sorry?
That sounds like very good advice, actually. I was asked to do a DNA test.
Yeah.
A newspaper asked me if I'd do a DNA test, and I suppose, actually, had I listened to Sean here, I might have been more tempted to do it. It just seemed like a very, very, very big decision, and I sort of didn't really want to know. Actually, I'm very interested by the idea you can tell musical ability or sporting ability by doing it. I mean, you just have to look at your children and put a football in front of them. They can't kick it. You don't need to do a DNA test. I mean, it seems to me they're very serious. I mean, the Huntington's thing seems very, very important to me. Whether they're going to be good at music or not, it's just pushy parents getting over themselves, really. I think we should reserve it for things that are really, really important.
Well, thank goodness for pushy parents if you love music. That's all right. What about you, Craig? Are you jumping the gun here?
No, I don't think so. We cracked the human genome only 12 years ago, and there's still so much more to learn. My paternal grandfather died of Alzheimer's a few years ago. I took a test last year, and I found out I had a low risk of suffering with Alzheimer's.
What was it
later in
like
life.
waiting for the results, or just when you were about to
It was
get...
horrible. It was really horrible.
But what did you think you would do if you knew? I mean, how would it make a difference?
Well, the company I took it with had genetic counselling available, and there must be safeguards.
But even so, even if they counselled you really well, what were you going to do for the rest of your life other than think, oh, God, very soon this is going to happen
Well,
to
there
me?
are certain things you can do to manage the onset. I can plan my life better, I can save for my retirement better, I can inform my family. If I knew I was
And then
going to
you're
suffer with
fine, ultimately.
Alzheimer's,
So you've,
then I would change the way I would live my life, and unfortunately I don't, and I have amazing peace of mind because of that.
If somebody in this audience, hopefully not, was to be diagnosed as having Alzheimer's from one of the tests that you might carry out, what would you say to them?
Generally, these are going to be people who have got a family history of it already.
Is it
and
definite,
if we've identified a specific genetic factor that what we know is what we call highly penetrant, it means if you've got this, you're very, very likely to get the condition. We would want to sit them down and talk to them about that and actually ask those questions. Are you sure you want to know? And it's entirely reasonable for people to say, I don't want to face this right now. I want to know maybe later on down the line, or maybe might want to think about it at some other
If I
stage.
say, go on, Shane, tell me.
Then I'll take you through a process. It might last a couple of months of counselling, of information giving, of making sure that you understand what
And
you're
how do
doing,
I live my life
and
from now on?
training you. And you know what? You live your life according to the way you want to live your life. I'm not going to tell people to do one thing or another. That's for people to
Can I make a
that
difference?
decision.
Wait, no, please,
Yeah,
please.
it is.
Can I make a difference with knowing that might be on the horizon with lifestyle?
It may make a difference in terms of what you decide then that you want to do in terms of planning for the future, in terms of possibly even careers.
Should I stop drinking? Is that a question?
That's a possibility, but these are big questions that then you have to ask and address personally. So when we take people through this, we say to them, look, you can't back out of this at any stage. If you find out you do
Well,
want
we're going to have to end there. Listen, thank you all so much for your contributions. Thank you, Shane. Thank you for that.